All right, this is for the mole lab. So a mole, each of these containers contains 1 mole of atoms of a single element. So that means each container is going to hold 6.022 times 10 to the 23rd atoms of whatever element is inside. So they all contain the same number of particles, but what you're going to see is they all have different masses. Okay, so sample number 1. We're going to put this on the scale. 71.1 grams for sample 1. And then the mass of the container with the cap included, just the mass of the container is 12.44 grams. And so what you're going to do on your paper is you're going to take this mass and subtract this mass, and that will tell you what is the mass of what is inside this container. So you can see the sample here. I'm trying to move so you don't see the glare. Okay, so this element, you're going to be able to look up this element on the periodic table by the mass that you got when you do this 71.1 minus 12.44. That mass should line up with a mass that is on the periodic table. And there's a bank at the bottom of your paper for what is possible, what elements we have in these 12 containers. Okay, so that is sample number 1. Sample number 2, 40.6 grams. And the mass of the container is 12.54 grams. And there's a good look at the sample. Sample number 3. Mass is 24.5 grams. The container is 12.49 grams. Here's a look at what is inside the container. Sample number 4. 64.3 grams. And the mass of the container is 12.39 grams. And here's a good look at the sample inside the container. Number 5, 77.8 grams. 12.50 grams for the container. And there you can see what the element looks like. Number 6, 68.3 grams. Let that focus. And the container is 12.47. There we go. And inside the container, here's what it looks like. Okay. Number 7, 130.9 grams. And the container has a mass of 12.34 grams. And inside, that's what it looks like. Number 8, 219.2 grams. And the container is 12.27 grams. And this is what the sample looks like. Sample number 9, 44.5 grams. And the container is 12.49 grams. And this is what it looks like. Sample number 10, 36.8 grams. The container has a mass of 12.48 grams. And this is what it looks like inside. Sample 11, 75.9 grams, and the container is 12.38 grams. And there's what the sample looks like. And our last sample, 12, 39.4 grams. The container is 12.40 grams. And then here is what it looks like. So as you can see, they all had different masses because they're all made of different particles. They have different numbers of protons and neutrons because they are different elements. But they all contain the same number of atoms on the inside. 6.022 times 10 to the 23rd atoms, and that number is what we call the mole. Anything, you can have a mole of anything. As long as you have 6.022 times 10 to the 23rd things, you have a mole of things. Just like anything can be, you can have a dozen of anything, and you would have 12 of that. Same thing with the mole.